Okay, we're going to perform an analysis of the rational function in example 8D from notes 4.1 days 2 and 3. To begin, we're going to factor the numerator and the denominator. So the numerator, first we're going to take out the greatest common factor, which is x, leaving us with x squared plus 3x minus 10. And in the denominator, we have a trinomial that factors as x plus 5 times x plus 4. And then we're going to go ahead and factor completely. So we can factor the trinomial in the numerator as x plus 5 times x minus 2. And the denominator will stay as x plus 5 times x plus 4. And I'm going to write down the simplified expression. So the simplified function would occur if we canceled out that x plus 5 factor. So that's going to be x times x minus 2 over x plus 4. And remember, we have to restrict that x cannot equal negative 5 because that's not part of the domain. Now we're going to go on with our analysis. So to begin with, let's find the y-intercept. To find the y-intercept of any type of function, we let x equal 0. So we're going to evaluate f of 0. We use the original function, not the factored form. In that case, in here, that's going to be 0 over 20, which is 0. So the y-intercept, written as an ordered pair, is 0, 0. Next, let's find the x-intercept, or intercepts. The x-intercepts, to find them, we're looking for values that make the numerator equal to 0, but the denominator cannot be 0, because if the denominator equals 0, those x values are not part of the domain. So we're going to look up here at the factored form of our function. We see when we have the factor x, that gives us the ordered pair 0, 0 with odd multiplicity. The factor x plus 5 does not give us an x-intercept because x plus 5 is a factor in the denominator, so negative 5 is not part of the domain. The factor x minus 2 gives us an x-intercept at the ordered pair 2, 0 with odd multiplicity. Next, we will look for vertical asymptotes. Vertical asymptotes are values that make the denominator equal to 0, and they come from factors that we cannot cancel out in the denominator. So the 0 in the denominator has to be greater than the multiplicity of the 0 in the numerator. In this case, so most of the time we want the numerator to not be 0. Here we're going to have a vertical asymptote at x equals negative 4 coming from this factor, the x plus 4, with odd multiplicity. The factor x plus 5 does not give us a vertical asymptote because x plus 5 is a common factor to the numerator and the denominator. So in this case, we just have one vertical asymptote. Let's look for holes. Holes occur when we have common factors in the numerator and the denominator, and it has to be a factor that we can cancel out of the denominator. That will give us a hole. In this case, the factor x plus 5 is common to the numerator and the denominator, so we are going to have a hole at the x value equal to negative 5. To find the y value, we're going to use the simplified function, or the simplified expression. If we went and tried to substitute into the original function, we'd get 0 over 0, which we cannot interpret. So let's use the simplified function, which is x times x minus 2 over x plus 4. So we're going to substitute negative 5 there. So we're going to have negative 5 times negative 7 over negative 7 plus 4, which is negative 3, which is going to give us 35 over... the denominator is negative 5 plus 4, which is negative 1. So it's 35 over negative 1, which is negative 35. So we're going to have a hole at the point negative 5, comma, negative 35. Next, we're going to go on and analyze infinite asymptotes. Okay, infinite asymptotes are describing end behavior. Okay, to determine infinite asymptotes, we're going to look at the degree of the numerator and the degree of the denominator. Here, the degree of the numerator is 3. The degree of the denominator is 2. N is greater than D. The degree of the numerator is greater than the denominator. So we have no horizontal asymptote. But the degree of the numerator is exactly 1 more than the degree of the denominator. So we have a slant asymptote, because the degree of the numerator is exactly 1 more than the degree of the denominator. To find the equation of the slant asymptote, we are going to have to use division. Okay, so we're going to use division to find the equation. And in this case, we have to use long division, not synthetic division, because the denominator is not of the form x minus k. So we're going to go ahead, we're going to set up our long division. We're going to look for missing terms, which in this case, we have 1, which we have to put a 0 at the end because we don't have the constant term. And on the outside of the division, we're going to put x squared plus 9x plus 20. And then we're going to go ahead and do our long division. So we're going to ask ourselves, how many times does x squared go into x cubed? That goes x times. We put that above the 10x term, and then we're going to multiply. So we're going to get x cubed plus 9x squared plus 20x. Then we're going to subtract. When we subtract, we're going to get negative 6x squared. Negative 10x minus 20x is negative 30x. And then we're going to bring down the 0. And then we're going to ask yourself again, how many times does x squared go into negative 6x squared? That goes in negative 6 times. So then we're going to go ahead and multiply, which is going to give us negative 6x squared minus 54x minus 120. And then we're going to subtract. When we subtract that, we're going to get negative 30 minus negative 54, which is going to be positive 24x. And then we're going to have 0 minus negative 120, which is plus 120. In terms of our slant asymptote, we are only concerned about the quotient. So we have a slant asymptote with an equation of y equals x minus 6. That's our slant asymptote, y equals x minus 6. And the last thing that we want to know is, does our graph cross this slant asymptote? So let's go ahead and do that analysis. So to determine if the graph, I'll do that over here, I guess I'll do it right here, does graph cross slant asymptote? Okay, so we're going to set our original equation, which was x cubed plus 3x squared minus 10x over x squared plus 9x plus 20. We're going to set that equal to x minus 6. We're going to multiply both sides by the denominator. So we're going to have x cubed plus 3x squared minus 10x is equal to x cubed plus 9x squared plus 20x minus 6x squared minus 54x minus 120. And then we'll simplify. We can cancel out the x cubed term right away. And then we're going to have 3x squared minus 10x is equal to 3x squared minus 34x minus 120. 3x squares are going to cancel out. We can bring the 34x to the other side. So 24x equals negative 120. And we're going to get x is equal to negative 5. So our graph is going to cross the slant asymptote at x equals negative 5 as long as x equals negative 5 is part of the domain. But here, x equals -5 is not part of the domain. That's where we have the hole. So we conclude that the graph does not cross the slant asymptote.